In this lecture, we will simply discuss about the Laplace additive smoothing, and we will see how we are using the Naïve technique for a text classifications. In just previous lectures, we have seen these three. Now, the main problem is that if our text corpus means if we have some data sets, and suppose our query point is such that in our data set this query point is not occurred. So in such situations, what will happen and how to get rid of from this kind of problem? So let's see one by one. Let's see step by step. So what we are doing in the training step, if we just consider only the training step, if we just simple considering the training step, so what we have actually have to done in training step, we are actually doing in training step that we have to find the likelihood probabilities and also the classifiers. So if we consider the binary classifications, then we are interested to calculate it this first the pair probabilities, that is the another you can call this is the class probability. If we have binary classifier and we are interested to this thing is called the class pairs. Classifier probability, and another we have to calculate the likelihood probability. So likelihood probability means what? If we have, suppose if we have m number for the text, if we have n number of word, then we are interested to calculate it for each word this likelihood probability equals to 1, and for word 1 for given class label y is equals to 0. Similarly for word 2 y is equals to 1 for word 2 for class 0. For word 3 given class is equals to 1, probability of y3 given class is equals to 1. We have seen, and if we have m number of words, word m for given class is equals to 1, sorry, it will be 0. This thing is, we have simple call this thing is our likelihood probability. Okay, simple, we have seen this thing in previous lecture. Okay, so just I am repeating this thing again. Now the problem is, suppose this is our actually our text, suppose our text purpose is like that. Suppose this is our text data in training, suppose training test data. Training purpose I am using another color. Suppose we have the training text data. Suppose let's take it in our training text data, we have m number of words, w1 w2 w3 up to wm. We have only text data in our whole training text data, we have only m number of words. Okay, just we have seen this thing. Okay, let's take, and if we see that suppose we have a text query text, that is our query text. In runtime we have to find the class level of this query text. So in this query text, if we see this query text contains this word, suppose w1 w2 w3, and suppose another word that is w dash. This word is totally not appear not appear in the training data set. So what will happen in such situations? So okay, just see the situations here. Actually what happened here, simply this w dash, and so in the query text the main problem is this w dash. Suppose let w dash is not present is not present in our training text data set. Okay, training text data set means suppose this thing we have called, this thing is, suppose let's take this thing is our dtrain. Okay, is not present in our dtrain data in, or another language, that is w1, w2, wm. It is not present in here. So this thing we naturally have seen many of tons of in real cases we have simple seen this thing. Okay, now what if we just interest to calculate the probability, just what we are doing in runtime, just see this thing in runtime. What we are interested to calculate it, this we are interested to calculate it, the probability of 1 for probability of class level 1 for the given this text query text, and we are interested just we are considering the binary case only and binary classifications only. So after giving this query 10 in runtime in text in the test purpose, in the test after training we have to, when we have to test this model, so for this query point we have to calculate these two probabilities, that is probability of class level 1 for the given query point and probability of class level 0 for this given query point. Okay, so what will be this thing, just clearly write this thing. So I think these two things are same kind of probability, just we have to change the class level only, nothing else. So just see this portion. So I think if you understand this portion, these portions will be trivial for you. So just see the first class level one. So text query text means what? Query text means this over query text means over and over 1 over 2 over 3 and over w dash, actually this thing. So how will calculate this one? Just see the Naïve, just remember our Naïve based formulations. First we have to calculate the classifiers, that is probability of y is equals to 1, then we are interested to calculate it w1 1, probability of w2 given classes y is equals to 1, probability of w3 given classes w1, and as well we are interested to calculate it probability of w dash. Okay, I think these three things, the first four things are clear. We are simple calculated this find this value from this training set. Okay, this training part, from the training set we can easily find this value, but the main problem is here. How we will find this value, how do we calculate it? Because in our training set w dash is not occur, so we are not know about some probability of this thing. So if you just ignore this simple, because we have no any informations in our training set for this one, just simple ignore this. If we ignore this thing, if we ignore this thing, so ignoring it means what? Ignoring it, or anyone called dropping it. If we drop it means what? If you ignoring this thing or dropping this thing means simple, we are taking this probability value is equals to 1. Okay, then only we can ignore it. So simple, we are using this value is equals to 1, then only we can drop this thing. So if you just taken this value is equals to 1, then what happened? Just taking the total whole probability. But is it this thing is totally wrong. This thing is totally wrong, because we have taken the probability is equals to 1, means in training set we have already considered this word. So I think this thing means totally wrong assumptions. So, or you can say, sir, just take the 0, just take y dash equals to 0. If you take this probability as well 0, then what happened? Then the total probability of this thing is equals to 0. This is not originally true. This thing is also not originally true, because this probability is not actually not equals to 0. So how to get rid of from these situations? Okay, this is the main thing. If you just ignore this word, this means if you using this equals to 1, then simply if you have just taking the considerations of the probability. Okay, and if you just taking the 0, then the whole thing will be 0. That is also not a good thing. Okay, so how to get rid of from this problem? So let's take let's write the probability. This means what? Let's write down. So probability of w dash is equals to 1 means what? Just if you just write the using the probability definitions here, so this thing means first in denominator what is, just we are using the definitions of conditional probability 1, and in numerator it will be probability of y dash and also 1. This is simple. We are using the definitions of conditional probability. So this thing means what? This probability of these things means number of training points. Just if you see our training data sets, so number of points, number of training points where sample y is equals to 1, and in the numerator means what? Numerator means training points such that w dash occurs and y is equals to 1. Just to have seen the both the case, if our class level is 1, and in class level 1, how many times this w dash occurs? So we see that in training data sets w dash is totally disappear, totally there have no any word in w dash. So this probability now will be 0. So this probability will be 0. So if you suppose let's take our number of points. Suppose n is equals to number of data points in the training data, number of train data. Suppose let's take, and among this n train data, suppose let's take n1. Suppose let's take among these n data points, our n1 is equals to our n1. Our n1 is equals to number of training data where y is equals to 1 for class level 1. So number of train data where our class level is equals to 1. So simple, this y1 is less than of n, because okay, so I think now this value will be 0 by 1. This sample value will be 0. Okay, we have seen this thing. This sample value will be 0. So for same case, if this value will 0 for class 1, for similarly this value will be 0 for same process, this value will be 0 for class 0 also. This value will be 0. As just using the same calculation, we can see that this value will be 0. Now to get rid of this problem, if this two value is 0, just this total probability is 0. This is not a right thing. So to get rid of this problem, we have used the Laplace smoothing concept. So let's see what is Laplace smoothing. What is Laplace smoothing? So just Laplace smoothing, just you don't confuse Laplace smoothing. When we going to the image processing chapter, then we have seen there have one thing, Laplacian smoothing. So these two things not equal. Laplace smoothing and Laplacian smoothing, these two things are not equal. So simply Laplacian smoothing we are using in image processing. This thing is used in image processing chapter. But simple Laplace smoothing we are using Naïve base to get rid of the unknown text problem. Okay, so let's see step by step. Or many author is called as additive smoothing also. Additive smoothing. Additive smoothing. Laplace smoothing or additive smoothing. Both are the same thing. Don't be confused. So let's take what is this thing. So actually we are interested to calculate this probability of y dash for the class level 1 and as well for the class level 0. Just we are considering the for class level 1, and this same thing we have calculated in class level 0 also. So first see the for class level 1 how it is applying the Laplace smoothing. So for class level 1 we have seen that our in numerator we got the zero value. And in denominator we have taken here our n1 number of data points for class level y is equals to 1. So to just Laplace smoothing is nothing, just we have add two terms alpha. Now we are speaking what is alpha, and we have add this alpha numerator and as well as we have add this alpha denominator also and 1k. So to get rid of this zero problem, okay, just if we not add this alpha, we have simple taking the zero value, but just to get rid of from this zeros problem, just we have adding the alpha for numerator as well as adding the alpha for denominator. Okay, so this k, now the thing is this k is what? First let's see this k, then we have seen what is the interpretation of alpha and what is the interpretation of k. So here k is nothing, our sample k is equals to number of distinct values, okay, that w dash can take. So again I am remembering w dash is nothing, this is our unknown word in our query data point. This is the w dash. So w dash with the number of distinct value that of w dash can take. This is the sample. This is the sample thing. Okay. So here we have in this example. So how many? Just here we have taken the binary classifier simply. So how much value k can take? Distinct value of w dash that can take. So the how much value w dash can take? Just simple see this thing. So in data corpus w dash may happen or may not happen. Only two type of value w dash can take. Here w dash on take only two values. Simple, just see this w dash. Just see this w dash. W dash only can two values, can take two values. If w dash present in our data corpus, then our sample we have taken 1. If present, if it is not present in our data corpus, then we have taken 0. So w dash can take in this example two values. So here sample in this example we are taking constant k is equals to 2, but there have many type of classifiers. if they are a multi-class classifier, so they are, then we can see then k can take many values. So in general, here just we have discussed this example. Here our w can take only 2 values, so here k will be 2. Okay, I think this thing is up to this thing you have clear all the thing. Now let's see what is the interpretations of alpha. What is the mean? So just to discuss the interpretations, just remember, so in generally typically this alpha is taken the 1. We have taken this value alpha is 1. Just before going to the interpretations of this alpha, just remember, in typically we have taken alpha is equals to 1. Typically we have taken this alpha value is equals to 1, and when we have taken the this alpha is equals to 1, so some authors are called it that at one smoothing, at one smoothing. Okay, because of alpha here in generally we have taken alpha is equals to 1, so because of that many authors calling at one smoothing, because you are adding 1, nothing else. So let's see what is the geometrical what is the actual intuitions, what is the interpretations of taking alphas here. So let's see these examples. Where example, so where we are interested to calculate it, w dash y is equals to 1, we are interested calculated this probability, and this probability of what, this is 0 but alpha, and let's take our n1 is equals to 100. Let's take n1 is 100 means what, in our training data set, let our training data sets number of points in class 1, that is n1, we have taken this value is equals to sample 100. Okay, so our denominator will be 100 plus alpha k. So here in this example we have taken k is equals to 2. Here k is equals to 2 because we consider binary classifier. Simple, because of this here we have taken alpha k is equals to 2, nothing else. I think you think, and you can ask one question that sir, why we are just taking this kind of smoothing, because we have just interest to ignore this probability, ignore this word. So instead of taking this thing, if you we can simply use just taking some small value, that is epsilon. Just if you simple, you can take some small values, that is take a small arbitrary random number, small random number, you can easily take. Okay, so why we are taking this kind of complex mathematics here, what is this reason behind it? So let's see why we can take this kind of situations. Okay, let's see. So first we have discussed this thing case by case. So let's case 1 first. Let's case 1. So let's see first case 1. Case 1. So first we are taking the value alpha is equals to 1. Now we are interested to increase the value of alpha. Okay, simple, if we have increased the value of alpha and if we decrease the value of alpha, let's see what happen in such situations. So first take alpha is equals to 1. So if we take simple alpha is equals to 1, so in this situation, so what will be this probability value? So simple, the probability of y is equals to 1 here will be what? এই চলছে অনলাইনে ক্লাস. So what will be this value? So if you just put these equations, alpha is equals to 1, so what we'll get? We get that if we put alpha is equals to 1 and here it will be 102. So now this probability will be 1 by 102. Okay, this is sample not is equals to 0. Okay, I think now clear. And this is will be a small value. Okay, now let's take one value. I think in case 2, let's take alpha is equals to suppose 10k, 10,000. Let's take, we have taken here 10,000 value, 10,000. So now what will be this probability in these cases? W dash by y is equals to 1, and now this probability will be what? This probability will be 1,000, 10,000, 1,000, 10,000, 10,002 plus 100 plus 2,000, 20,000, sorry, 20,000, 2,000, 20,000. So now this will be okay, and is approximate equal to 101 by 2. Okay, we just see, if we have taken alpha is equals to 1, then this 1 will be so small, that is tends to 0. If we have alpha is equals to 1, it is small value, but when we just going to increase the value, this probability will this probability will be now tend to half. Okay, what is actually this means? This means that if this probability is tends to half, this means if this one is hard, similarly we get w dash y is equals to it, similar for same thing it will be also half for same thing. So we have seen that if we just increase this value of alpha, then both the probability for class 1 as well as for class 0, these two probabilities is same as equals to half, tends to. So it's simple. If we just summarize this thing, if we increase the value of alpha, then what? Then probability of w dash with class 1 is equals to 1 is equals to probability of w dash with class level is equals, given class level is equals to 0, is nothing half. Okay, I think this thing is clear. So this thing means if we have simple by simple changing the value, we have considering that this, what is this means, actual interpretations of this means what? This means we have interpreted that our unknown w dash mean our unknown word. For this unknown word, the probability of its occurring in class 1 and its occurring in class 0 both is the same probability, that is half. Okay, by simple increasing the value, we have just approximated this probability for the both class are same. Okay, this is main simple intuitions of this Laplace smoothing. Okay, so the one thing is that if you think, sir, we have only applied this Laplace smoothing for the unknown word. So this is not, we are in Laplace smoothing, we are applying this Laplace smoothing for all the training data sets. Okay, this Laplace smoothing we are applying for all our training data set. Example, this we have applied for all the training, for all the words. Okay, simple, we are using this thing for all the words, that is in present my words that present in my training data. Okay, I think now this thing is clear, all of you. Now let's take just I am here using alpha is equals to 1, and then we simple increase the value alpha is equals to 10,000, and we see when we just simple increase the value of alpha, then we got that the probability for this unknown word for each classes will be tends to same. Okay, tends to same probability it will be, that is half. So now let's increase the value alpha one by one. Okay, suppose let's take one value. Here we are what using, here we are using n1 is equals to 100. Now we are simple same, I am considering our number of data points in the training is small. So let's take, let now our n1 is equals to 50. So consider small data set in our training data set. Consider small data in training set. So in such situations, what happened? Let's see. So now we are interested to calculate this value. We are calculated P of Wi for all data set. Actually, we are using this thing for all the data sets, for all the, not for only unknown data set, for all the data sets. Y is equals to 1. So this thing will be W1. Let's take our this value alpha by 50 for all. Suppose this one, suppose our Wi that is belongs to our training data, retrain, and the probability of and the probability of this Wi with class level y is equals to 1 is equals to, suppose let's take this thing, this probability is suppose 2 by something. Suppose let's take 2 by means our 50, and number of say data points. Suppose let's take this is the probability. Suppose let's take our numerator now. Just don't be confused about all the term, just to make it simple. For this situation, let's take our probability is 2 by 50, and here we are using alpha case smooth, Laplacian smoothing. I'm using add this both term here. So this is probability thing, and I am applying simple our probability of equals to, let's see, it is probability of this thing, and here we are applying the Laplace smoothing. Simple, we are using the Laplace smoothing here. Okay, so now put first. So first we are putting the alpha is equals to 1 value. Let's say what will be the value now. This value will be, if we putting alpha is equals to 1, this value will be 2 plus 1, 50 plus k. Here k is equals to what? K is equals to, we have 2. So this value will be what? That is 2. 2 alpha is equals to, we have putting 1, and k is equals to 2. So this thing will be alpha 1, k is equals to 2. This thing will be 3 by 52. Okay, I think everything is okay. No, okay, everything is okay, no problem. Now let's see alpha is equals to 10. What happened in such situations? 2 plus alpha is equals to 2, alpha is equals to 10 plus 50 plus 2 into, that is k is equals to 2, 2 into 10, that is 20. So this thing now will be 12 by 70. Now let's take alpha is equals to 100. Just we are comparing how this changes, value will change. 2 by 50, alpha is equals to 100, and this thing is equals to 200. So now this value will be 102 by 250. Let's take alpha is equals to 1000. What happened this stage? 2 by 50,000 plus 2000. So this value will be 1002 divided by 2050. Okay, if you see, when we just simple increasing the value of alpha, simple we are increase the value of alpha. So the value of this probability is increased. So this thing is approximate is equals to 102, a half. This probability is approximate is equals to 102, but this probability less than is equals to 1 half. This probability more or less half. This probability less half. So if you see, just by simple increasing the value of alpha, increase the value of alpha, this probability value is increased towards half. So this probability value increased towards half, means by simple increasing the value we are taking that probability half, means our considered probability for our all the classes, our considered probability for all the words which is same for it will we are simple considering the words, all the words, it will be positive classes and also it will be negative classes. Okay, simple if you just write this thing in one word, simple by increasing the value of alpha we are moving, these are all the likelihoods probability, these all the things are likelihood probability, this one is the what, this is actually the likelihood probability. Likelihood probability, so by moving, simple moving likelihood probabilities to a uniform distribution, to a simple by we have seen that when we have alpha is equals to 1, this probability is so small. When simple we have increased this probability, our this total our this probability likelihood probability is something increased. So when we are going to increase this value of alpha, so this probability will tends to half, means this probability, all the probability likelihood probability are going to uniformly distributed, means all the probability has to occur in same chances. Okay, this is means that, so simple n1 is small, n1 is small means what, this small means our, if our n1 is small, this means our numerator or denominator, numerator and denominator is small. Okay, we have seen this, if our n1 is equals to, we have taken 50 only, so we have seen that our, in such cases if we n1 is equals to 50, then numerator is small as well as our denominator is small. In these cases we have less confidence, in such cases we have less confidence, less confidence. Okay, in all the word. Simple is means that if we have applying the Laplace smoothing and our n1, our that is number of data sets in is data number of data set is small, then we are simple, this means we are less confidence in all the classes. Okay, in all the, for all the words we are less confidence, all the classes. For h over we are less confidence for all the classes. This means that less confidence means we have taken sample, our probability is half. Okay, you can easily see that, you can easily see. And now this alpha, in the next part of this video we have seen that this alpha, we are simple using the alpha as a hyperparameter to maintain the wire between bias and variances. We have seen that in the next videos of this series. We have taken here alpha actually to take as a hyperparameter to maintain the wire between bias and variances. I think the intuitions of this alpha, why we have not using simple small value, where we are using this kind of smoothing technique, mathematics technique. I think it is clear, all of you. Okay. Best I am just again repeating this concept simply. If we have a sum in our query data set, if we have a wire that is totally unknown from our training data sets, so in such situations we are unable to find the likelihood probability of this unknown word. So if you just ignore this, for example dropping this likelihood probability for this unknown word, so simple we are just using the one, then it is not that true assumptions. Or simple if we taking the zero value by simple ignore it, means if you just simple the zero value, so our total likelihood probability will be zero. This is not also a same wrong, this is also totally wrong thing. So to avoid some kind of problems, we are using the Laplace smoothing. So I think the Laplace smoothing is here we are simple not using for our single unknown words. Here this Laplace smoothing is we have using for all the training data sets. And we have seen that for this Laplace smoothing, this alpha is simple. If we increase the value of alpha, then the likelihood probability is going to tends to a uniform distributions. That is, this likelihood probability value will tends to half for both the classes. So because by simple increasing the value of alpha, by increasing the value of alpha, our this likelihood probability is going to the uniform distributions, means we are added some bias to our model. Okay, I think when we are discussing the bias variance trade-off hyperparameter tuning, then I think this thing we have clearly shown. Now I think the intuitions of this lecture, all of you clear what is Laplace smoothing, and why we are using this kind of smoothing and why it is required. I think this kind of concept is clear, all of you. Okay.